This is Professor Iris Miano again with a Math 50 lecture video. This is day 15 concerning just one section, so it'll be relatively short. That's section 4.3 on box plots, one of my favorite topics in this course. I don't know what it is, but I think I just find it very satisfying to represent data in this fashion. I just think they're cute. I think they're fun to make. And hopefully by the end of this lecture video, if you have had some pretty grody feelings about box plots in the past, if you've had some sort of pre-statistics or even a statistics class in your mathematical pathway before and any of this stuff has not made sense, I really hope, I sincerely really hope that this makes sense for you now, okay? So let's break down all of the information, and we're going to review how to make our calculator give us this information once we feed the data into it appropriately. So definitely go over the steps for that. I'm not going to bother with writing down the steps because that's in the previous lecture video, day 14, on sections 4.1 and 4.2. So go back to that video if you're like, oh, I forgot the steps, or I want to look at a visual of what the buttons are to push. I will certainly describe them as I go. So if you have your calculator handy, definitely follow along with me in the demonstration of that by just listening to which buttons I push. Anywho, before we get into all of that, we need to define a series of terms starting with various quartiles. So quartiles I'm actually going to fill out this bottom part first. What are quartiles and what do they do? Well, they are values that split the data into 4 equally sized pieces. So they will divide the data into quarters. So 4 equally sized pieces. 4 equal pieces, I'll say, parenthetically. So you need 3 different values plus 2 more. There's actually a 5-number summary that we'll get down to in just a moment. But the 3 values that haven't been defined yet are the first, second, and third quartile. So the first quartile, which is denoted by Q sub 1, is the 25th percentile of the data. Q1, also 25th percentile of the data, which is to say that the bottom 25% of the data lies below this Q1 value. Q2, which can be written as Q2, Q sub 2, or it's also called the median. So this is a 1, sorry, a Q1, and then that's a comma, I guess we'll say. 50th percentile is another way of representing this. And then lastly, the third quartile, denoted by Q sub 3, that is also known as the 75th percentile. Okay, let's get into some box plot stuff. Oh, here we go. Some more things to define. 5 numbers that summarize the data using, so the 5-number summary is the minimum value, the Q1 value, Q2, that's a Q1, comma, Q2, Q3, and then the maximum value. So you need all 5 of those numbers in order to draw your box plot. So the box plot, here's an example of one right here for test scores. And it's a visualization of the data using the 5-number summary. And in this example, I will go ahead and label the 5-number summary here. We can tell by virtue of this whisker endpoint, yes, so this is called a whisker right here. Whisker. Like a kitty. Meow. This is another whisker. The bottom of the lower whisker is the minimum value right here. The edge of the box, the leftmost edge that is, that's your Q1 value. This vertical line inside of the box is your Q2 or your median. Go ahead and label them both that way. And then this upper edge or larger edge is Q3, and then as you might from context clues be able to discern here, this end of the upper whisker is your maximum value. Okay, cool. So that's where your 5-number summary all lives. Great, let's go ahead and take a real data set here, and it's the students in the author statistics class are asked how many people live in their households, including themselves. The replies of 12 students are given in the table. Okay, so we have 12 data points, and we're going to feed them into our TI-84 plus or TI-83 plus calculator in order to get the 5-number summary, because as you might recall, the first time we talked about the one variable stats output, when we first started using that part of our calculator, we were outputted with min, max, Q1, median, and Q3. So let's go ahead and do that series of steps again with this new data set in order to find all of those values. We'll note the 5-number summary for part A, and we'll use it to create a box plot. So fun. Okay. So go grab your calculator and go to Stat. Okay, so Stat is going to be the first button that you push. And then for the Edit drop-down menu, it's the first defaulted value is going to be number 1, Edit ... Go ahead and press Enter. And if you have data already in your L1 column, go ahead and toggle up to highlight L1, press the Clear button, and then toggle back down to the area where you're going to feed in your data. And then start feeding in your data. So I'm going to do that with you. So I usually feed it in by rows. So I'll go with the first row of data saying 6, then toggle down, 3 down, 4 down, 3 down, 7 down, 4 down, 3 down, 4 down, 3 down, 2 down, 10 down, and then 3 is my last value. And yes, the last value should be the 12th one. And you get a little indication of that when you're feeding in your data. It should say on the very bottom of your screen, L1 parentheses 12 equals 3. That's just telling you that your 12th data point in L1 column, data column, is a value of 3. Okay, cool. So now that you've fed in all that data directly from there, you don't have to quit or anything like that. Just press Stat and toggle to Calculate. So Calc, that drop-down menu. And then the first thing that's highlighted is the one variable stats that we want. Press Enter. You will see one variable stats with a blinking cursor on your main page, your main screen. And we need not remind the system what column we're looking for. Like this is where you would put in L2 or L3 if you had your data in those other columns. Having data in no other columns, L1 is the default. So just press Enter, and you should see your one variable stats, starting with your X bar. Not that we need that. We're not grabbing that there, but that's just the first value of 4.3333 forever. But go ahead and toggle down to the second page where you're going to get n equals 12, min x equals 2, q1 equals 3. So start writing that stuff down. So here is my 5-number summary right here. The min value is 2. Our q1 value is 3. Median, or q2, is 3.5. Q3 equals 5. And the max value is 10. So we're going to keep all of these values in mind to create a box plot of the data. Okay, so you should have yourself a little bit of a kind of a graph area that you can give yourself. And we need to capture tick marks on the horizontal axis. And we can go, like, let's just do 10 tick marks, right? So that'll, and try and make them equidistant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll just do a couple more on there for funsies, okay? So 1, 2, 3, 4. Maybe I'll label the fifth one. 6, 7, 8, 9, 10, and leave it at that. Okay, so now we're ready to, and I'm gonna mix up the colors because it's just, I don't know, a bunch of fun to do that. And I'm going to start with the minimum value of 2. So that's right here, okay, at the second tick mark. So that'll give me the edge of my whisker, okay? So I'll just kind of put a little vertical line there. Now for the box, so I'll make my whiskers in green. I'll do my box up in, I don't know, orange, just for funsies. And my Q1 value is going to be at 3, so that's going to start off right here. So I'm going to try and line that up as well as I can. And my median is 3.5, so that'll be kind of a really thin rectangle here in my box, the first part, so that's 3.5. Trying to line that up. And my Q3 value is at 5, so I'll try and make that line up there. And go ahead and kind of close up my box there. Oops. That last, hold on. Gotta redo that bit. Okay, that looks fine. And then my upper whisker goes all the way up to 10. So I'll have my upper whisker go like that. So now is the time where it would be good to attach my whiskers to my box, like so. And isn't that fun and cute? Oh my god, I just love it. I think that's adorable. I'm trying to erase that little mark right there. Hold on. Hey. Okay, there we go. I want to erase it first. Okay, cool. So there's our box plot of our data. So let me just actually double check with the, yeah, because the original box plot didn't have all these extra labels to them, right? So it would be fine for us to leave those out, but we should label our horizontal axis and put a title to our box plot so we can uphold what's happening in that example pretty well. So the title should be something to the effect of how many people live in your household. Make it a question even. And then the units on the horizontal axis will be people. Cool. So that's what I would call, and I'm going to box it up in the hot pink color right there. I would call this a complete box plot. What you see in box up. And then of course the 5-number summary that we used to create it, I'll box that up in pink as well. Cute. All right, fantastic. What's the next example? We have another data set in which the author surveyed students of the statistics class regarding the one-way distances in miles they drove to college, and here are the replies of 11 students. Now here for this example, we are just simply asked to find the 5-number summary, not make a box plot for it, although we could. But let's just not do more than we need to do. This is good practice for us to use our calculators and put in the data. So again, the instructions are press the stat button, then press enter on the edit screen. Having highlighted the default number 1 edit ... press enter, and then clear L1 of its data. You don't need to save any of this stuff. You can always re-enter it later if you need to, or you're always just going to be going over fresh examples, really. So toggle up to L1 until it's highlighted, press the clear button, and then toggle back down. And the data that I'll be putting in is 10, down, 6, down, 7, down, 6, down, 5, down, 13, down, that's the first row. Now the second row, 20, down, 3, down, 3, down, 7, down, and 30. My goodness. So we have what looks to be kind of some extreme values on either side. Some people are really close to the college that they attend, and some people are 30 miles away, which is not super close. Okay, so that's their 11 data points. From there, after you've entered all 11 points, press Stat, toggle to Calculate, and press Enter on one variable stats. And then press Enter one more time to ask it for the one variable stats, and there you have it. So scroll all the way down to the second page, and you will get the information you need for the 5-number summary, which, as you recall, is, let me get a darker color here, the minimum value, the Q1, Q2, which is also the median, or median, Q3, and the max value. So the minimum value, according to my output here on the calculator, is 3, or you could, clearly see that from the data since the data set is not super huge. The Q1 value, though, something that they calculate, so that's 5. Median is 7. Q3 is 13. And the maximum number, of course, is that 30-mile commute. And that's that. That's all they asked us to do. So this was just another exercise and practicing using your calculator. Okay? Cool. So now we're going to start to talk about this idea of extreme values, values that lie outside the fences. What are fences? Well, they're calculations involving interquartile range. What is interquartile range? Well, let's go ahead and define that right now. So the interquartile range is governed by the difference between the Q3 value and the Q1 value. Okay? So this is an interquartile range. It's called IQR, and it is Q3 minus Q1. The interquartile range measures the middle 50% of observations. Okay, now in order to be able to determine if there are some really extreme values, some outliers actually, as they are defined there, you need to calculate fences, in which these basically are boundaries by which we hold in the more reasonable values of our data set, and anything outside of the fences is going to be considered an outlier, as you can see down below by the definition. So the left fence is calculated by Q1 minus 1.5 times the interquartile range, which itself is Q3 minus Q1. Whereas the right fence is calculated by taking Q3 and adding 1.5 times the interquartile range. And yes, and then the other thing here that is mentioned is this definition of an outlier. It's an outlier. An outlier is a data value that is outside of the fences. So it could either be, so outliers are either greater than the right fence, or less than the left fence. That's what I'll add to that definition. Okay, for the data of household sizes, find the outliers, if any. So I'm going to switch the color here to, let's go dark green. All right, so we need, what do we need? We need to first find the interquartile range, which is our Q3 minus Q1. Well, what was Q3 and Q1 for the household sizes? That was this data set, right? Okay. So Q3 and Q1 were 5 and 3 respectively. So the interquartile range will be 5 minus 3, which equals 2. Okay, IQR equals 2. Then let's calculate each fence, right? So the left fence will be Q1. I'll just rewrite the formula here. Minus 1.5 times the interquartile range. So plug and chug. What was Q1 again? Well, that was your 3 value minus 1.5 times the interquartile range of 2. Okay, so what's 1.5 times 2? That is a 3, okay? So sorry, whoops, made an error there. So that means 1.5 times 2 is 3, so your left fence is at 0, okay? Interesting. And then your right fence, so we don't have any values that are, less than 0, right? It would be impossible to have even less than one person in your household because you have to count yourself. So even though this left fence was accurately calculated, it doesn't actually represent any value that is possible given the context. But that's neither here nor there. So all this tells us is that we don't have any small outliers. But let's see if we have any large outliers. Okay, so the right fence is calculated as Q3 plus 1.5 times the interquartile range, which equals 5 plus 1.5 times 2. So that'll be 5 plus 3, which equals 8. Yes, check that out. So this is the the upper bound of what is considered to be reasonable data values. And check this out, we have this one value is larger than the right fence. Larger than the right fence, which is the 8. Okay, so it says, if there are any outliers, we just found one, the 10, redraw the box plot. Okay, so one thing you'll need to do when you are encountering an instance where you've drawn a box plot or you've considered one already, but you've calculated that there's an outlier or two and you need to redraw it, well then you need to take out the outlier from the data set only in regard to, though, finding the new maximum value. So therefore, this 7 is the new max. Okay, great. So all other pieces of information stay the same, and I'm even going to use the same colors that I did. Let me just remind myself it was the purple, orange, and green. Okay, so let's get all those colors back again. I'm going to use this purple for this business, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And whatever, we could do 11, 12 like we did last time. Let's go ahead and label this, what was the title of it again? I already forgot. How many people live in your house? How many people live in your house? Okay, let's label these tick marks just by 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's fine. You can have more tick marks if you want to. And we're labeling these, this is people. It looks like people. Hold on, let me write that one more time. Terrible handwriting. People. There we go. That's the units there. Okay, minimum value, still very much, oh, did I do green? I did green for that. It was orange for the box itself. The minimum value is still 2. Oop, right there. Maximum value is no longer 10. We're going to let that be an outlier. So the new max is going to be 7. So that'll go right here. Okay. And then the Q1, Q2, or median and Q3 values are still the same. So let me remind myself what those were. That'll be 3, 3.5, and 5. So 3, 3.5, all the way up to 5. Whoa. Oh, so cute. All right, here is the connections, the whiskers there. And then your outlier is generally represented by a dot. And I'm going to go ahead and use this dark green because that was the value, or the color that we used to calculate the value, and that was it was 10 was the one outlier. So I'm going to put a dot at 10, and that's our outlier. Cool, great. So whenever you have like a super long tail on one end, by tail I mean a super long whisker on one end or another, that may indicate that you have an outlier, and it warrants this extra series of calculations, interquartile range and left and right fence, in order to determine if you have any outliers according to the definition. Okay, because then you might want to redraw your box plot so that it looks more reasonable. Great. Let's go ahead and entertain a few examples of box plots as they lend themselves to another representation of frequency histograms. Okay, so notice that we have 4 frequency histograms listed here, numbers 5, 6, 7, and 8. And we'll see that in number 5, we have something that appears to be left skewed. Whereas in number 6 and 7, they both look to be pretty, unimodal, or not unimodal, but symmetric. They're all unimodal, by the way. I would call all of these unimodal because they only have one hump or one mound. 5 is certainly left skewed. 8 is right skewed for sure. And then 6 and 7 are both symmetric, looking. And but what are the differences between 6 and 7? Well, it looks to me like 6 has more, 6 has less spread in the data than 7 does, because look at the min and max values here. 34 versus 46 here for min and max, whereas the min and max values are closer to each other in regard to the distribution in figure in number 6. Okay. So take that information and then look here at their corresponding box plots, because the box plot is just another way of representing the data, right? So take that into consideration with being able to match these up. In fact, I'm going to go ahead and, oh, that's too far. I just want to be able to see all of these at the same time. Okay, great. Because look, what we have here are all 4 box plots on the same set of axes. And notice that all of them have the same Q2 value, okay? This one for part A appears to have some outliers to the right, so on the other side of the right fence. So that means there's going to be some extreme values to the right, kind of like how this tail is right here. And also what the minimum value is 38, that checks out with the whisker over here. So I would say that the box plot for part A is looking like number 8 here, okay? For part B, we have the opposite kind of thing going on here, where we have some extreme values in the left side, so the left tail here, and also its maximum values at 42. That checks out really well here as far as representing the number 6 figure. So I would say that number 6 is looking like B. And that just leaves being able to determine who is looking like C or D in the 2 symmetric. And I think, and I kind of gave it away a little bit earlier, that the spread is going to be the defining factor, because check this out. The box plot in part C has a minimum value of what? 30, closer to 34, maybe 35-ish, and then it goes all the way up to 46. That's looking like number 7. Whereas the less spread, 37 to 43, that matches up what's going on with number 6 here. Okay, so that'll be a C for this one here, and then D matches up lastly with that. Okay, cool. And that is a wrap on box plots. So hopefully that was a fun overview and you enjoyed yourself and you got to practice using your calculator a little bit more. Again, if you do not yet have a TI-84 Plus calculator at your disposal or a TI-83 Plus calculator at your disposal, for use of doing homework, practicing, studying, and taking exams, like you don't have to own it. If you could just borrow it regularly from someone else who might also be using it, I don't know, that might be a dangerous game to play if the other person that perhaps owns it and might be lending it out to you, if they need it at the same time as you, that could be a super big bummer. But I'm just saying, like, these are expensive things to get at. So if you can borrow from someone, cool. If the SMC Math Lab is still renting out calculators, I don't know that they are. I haven't heard either way. Maybe email Judith Mosher. That's MOSHER_JUDITH at smc.edu. Give her an email, shoot her a little message, and ask, and be super polite about it, and use good grammar and punctuation, just because she deserves it. She's a lovely, beautiful angel person. And get yourself this calculator. It's a very important part of this course, that you have access to this delightful machine. Cool. That's it for this particular video. I will catch you guys later.